Alright, so I lied. I don't have a black pill, but we can fix that. With all joking aside, my board is an older version of what would become the black pill STM32. It has the same IC, the F401cc, as most of the black pill boards, and the steps are basically the same. And just a note, some of the new black pill F4 boards use the STM32F411CE U6, which isn't supported in version 1.8 of the STM32 Arduino Core. When version 1.9 is out though, this tutorial should work with the F4112. Awesomely, these black pill F4 boards do not require a USB bootloader to be installed, as one is already programmed by default. This makes the process significantly easier than my previous tutorials for the blue pill. With that out of the way, let's get cracking. To start with, you need to make sure that you have STM32 Cube Programmer installed. You can find the link to install it in the description. Once you have the programmer installed, the only other thing you need to install is the Arduino Core for STM32. Go into the Arduino IDE and select File, Preferences. Copy this URL, which I have in the description, and paste it into additional board manager URLs. Next, go into Tools, Boards Manager, and search for STM32. Click Install on STM32 Cores by ST Microelectronics, and we are ready to go. Now we can simply open the Blink program from File, Examples, Basics, Blink, and change LED built-in to whatever pin your LED is on. In my case, that is pin PC13. My board has it labeled as D1, but you can see by the traces that it is connected to PC13. I'm also going to add serial.begin 115200 and serial.println hello world to set up and loop respectively, so we can see the USB in action. Now go to Tools, Board, and select Generic STM32F4 series. If your board has the F401cc chip, then set the board part number to black pill F401cc. If your board has an F411CE though, and version 1.9 of the Arduino Core for STM32 is out, you should select the option black pill F411CE. 1.8 is the current release though, so I don't have that option here. Finally, set USART support to Enabled Generic Serial, and set USB support to CDC Generic Serial Supersede USART. Set the upload method to STM32 Cube Programmer DFU. You should not need to select a serial port, but having one selected won't hurt the upload process. Alright, now we need to take a look at the board. My board has a reset button and 3 dip switches. The newer black pill versions have buttons, so I will give instructions for those too. First off, connect the USB to your computer and your board should turn on. Mine still has the default code running from the factory, which is why it is blinking. Now, if you have dip switches, set this dip switch, the boot 0 switch, to the on position, and press the reset button. If you have buttons, press and hold the boot 0 button, and then press and release the reset button. You can then release boot 0. The board should now be in Device Firmware Update mode, also known as DFU mode. In the Arduino IDE, you can now click Upload and it should work. You should see your LED blinking. If you don't see an upload success message and a blinking LED, retry pressing the buttons and dip switches and make sure that your USB cord supports data transfer. You should now be able to open the serial monitor after selecting the newly created serial port and see it saying Hello World. Make sure the baud rate is set to 115200 in the monitor. From now on, you can upload code by repeating the process of pressing boot 0 and reset, and then pressing upload in the IDE. If you have dip switches like me, you can leave boot 0 on and just press reset. If you have dip switches and want your code to run when power is applied, however, you must move the boot 0 dip to off. You will need to move it back to on and press reset to upload code again though, so while testing you can just leave it on. Finally, if you want to use this with Platform I/O, you can use this set of configurations. This is a super easy way to start uploading code, but it isn't the most convenient. You may want to invest in an ST-Link V2 as it is very fast, allows for chip debugging, and it can upload code without needing to press reset. This setup works very well with Platform I/O, and I will have a more detailed video about that coming soon. With that said, the idea for this video came from the STM32 Discord that I started, so if you want to ask questions, work on projects, or just talk, join with the link in the description. Take care, and happy coding. And I just want to thank Neil and Finn for looking over the script. Thanks, guys.